So Norrish type 1, we found that in a carbonyl R1, R2, this alpha cleavage happened. It's a alpha cleavage. But in Norrish type 2, it's a beta cleavage. So if I think that this is alpha, then this is going to the beta 1, that bond is going to cleave. So we found that if this bond cleaves, this is Norrish type 1, Norrish type 1, and if this bond is cleaved, that is Norrish type 2. Now the question will come when Norrish type 1. Norrish type 1 versus type 2. You have to identify the problem either type 1 or type 2. They will ask this kind of things. Now, I will come to the part later. Now, when Norrish type 2 will occur, as it's a beta cleavage, definitely there will be a relatively weak C alpha C beta bond. How is that? It is alpha carbon atom C alpha and this is C beta. If this bond become weak, then only this will break. So this is the requirement of Norrish type 2. A relatively weaker C alpha C beta bond. Fundamentally we have to understand this. Now the question will appear again one question when this C alpha and C beta bond weaker. So when it happens, first we understand we need a weak C alpha C beta bonds. Then when it happens, means when the C alpha C beta bonds become weaker. In the next example, I am going to show when it happens. Let us think about this cyclic ketone. So what will happen? Just same thing. Upon irradiation, this molecule, upon photoirradiations, this molecule go to excited state. It's a photoirradiation. This molecule is going to excited state. Now, as this bond is weaker, we denote the excited state by this symbol. This is going to cleave by Norrish type 2 manner. Type 2 manner. So, in this discussion, we have identified one fundamental point, that is, which is true about Norrish type 2 reaction. There should be a relatively weaker C alpha and C beta bond. Now we'll understand why it happens. Let us think about this molecule C double bond O CH3. Okay, then you think this is three member highly strained ring, very highly strained ring. As this is strained ring, these bond or these bonds are very weak because the ring are very strained. And also, if you remember that if we have this kind of carbocatonic structure, you know this, that sometimes this bond can delocalize into the few p orbitals. That is called dancing resonance. That is means these bonds are relatively weaker. Now among these molecules, now we have identified two bonds. One is this bond, another this bond. These two bonds are relatively weaker than these bonds. So these two will undergo cleavage during the photoirradiation. Now let us have a look what happens when it undergo photoirradiations. C double bond O, CH3, H nu. We have photoirradiated the molecules. Then now this bond is going to cleave homolytically, means in this fashion and in this fashion. So two radical will be there, and we have this one C double bond O, CH3. This is dot and this is dot. Okay. Then what can happen? Two things can happen. One thing that we have a H here, hydrogen atom. This hydrogen atom can migrate either in this place. Let us. This is path A. If it is go to breaks in such a fashion, we will have these things. If it migrates through path A, this one, we will have what we will have. We will have, means it will migrate into this center. So this is going to migrate to this center. So we will have now this hydrogen atom is here. We have one dot. This is another dot because it's a homolytic cleavage. C double bond O, CH3. It is nothing but this molecule O, CH3. Now, if this migrates to this center, it is bypath A, then bypath B, what we'll have? We'll have these things. This is dot, this is dot. Now this has migrated to here. We have hydrogen atom, the double bond O, CH3. This is nothing but these molecules. So we will have these two products. So definitely, then the question will be which will be the major product and which will be the minor product. This will be the major product. Major product. Why? As this is more substituted alkene, this is more stable. So more substituted alkene and it is more stable. Alkene and it is more stable. And this is less substituted alkene, so this will be a minor as it is less substituted. Okay. Now let us watch the outcome of these discussions. Simply this question has been given C double bond O, CH3, H nu. Then you can directly come to the conclusion that for this case, this uh, H CH3. This is going to be the, it's basically these two are same thing, just I have shifted by one carbon. This is going to be the product. So this is the outcome for these discussions. And what we learn from these discussions that cyclopentyl cyclopropyl ring being as very strained molecule, these two bonds are weak. That's why this undergo cleave in that position. Okay. Now And I forgot to say one thing. If you think about one, let's say it is one, two, three. Think about that. This is one, this is two, this is three. So one, three biradical, biradical. So two things we result from the discussion, assertion type questions. Number one, the requirement Cu alpha, C beta, weaker bond, and after that it proceeds to 1,3 biradical intermediate. Intermediate. We, we have to always remember these two golden points. Now I'm moving to the next example. Think about that these molecules C double bond O, and this is alpha, and this is beta. Again, this is three member ring. That's why it is strained and weak. Strained and weaker. As a result, after irradiation with H nu, it will clip in these positions. So we will have one dot here and another dot here. CH2, sorry, another dot will be here. One dot here, another dot here, and we have one H. Then the question, what is the fate of this intermediate? Look, 1, 2, 3. 1, 2, 3. That's it's also 1, 3 Y radical. Then what is the fate of this intermediate? Okay. Now, if this hydrogen atom migrates to the center, then what will happen? We will have these things. Double bond O, it is hydrogen atom. Now we have one dot here, and we have another dot here. It is going to migrate, leaving the another dot here. It means we will have this thing. We will have these things. Now, if this migrate to here, this carbon, then we will have C double bond O dot. Now it is this one because this has been on this carbon atom because of these migrations. We will have these compounds. Similarly, it is what? It's alpha beta unsaturated carbonyl compounds. Alpha beta unsaturated compounds, and it is more stable. Most this is minor. Okay, so it happens through 1 to hydride shift. So this is a very good point. That first point we should remember the required for the requirement of Norrish type 2, we should have a weaker C alpha C beta bond. Number two, it proceeds through 1,3 biradicals. Number three is that 1 to hydride or hydrogen shift happens. not hydride, hydrogen. Hydrogen atom shift happen. This type of things we have read during the molecular rearrangement. Sometimes we found that in Canniger reaction, hydride shift happens. Hydride, not hydrogen atom. Somehow we flashed that during a carbocationic rearrangement, that is a neopentyne Medivin Wagner Medivin rearrangement, hydride shift happened. But here we are finding a hydrogen atom H dot is going to migrate. So if the question is asked in such a way, in which reaction H dot migrate, we no need to worry. Definitely the answer is Norrish type 2. Never forget this point. Whatever the question come at whatever fundamental points, based on my previous discussion and present day discussion, you can answer all the things. So in Norrish type 2 reaction, iodide shift happens. Not hydride, is a mistake slip of the tongue. Hydrogen atom shifts. Noise type 2. Another thing here we have to remember, this is one C alpha C beta bond. There is another C alpha C beta bond. This one. If this one clip, then what we will have? We will have these things. So look, this has clipped. Now the new member is 1, 2, 3, 4, 5, 6, 7. A 7-member ring is formed. So I have to redraw it. 1, 2, 3, 4, 5, 6, 7. 7 ring formed. And we should have 3 y radical. So one radical will come just these points, right? So because of this one radical, a number 2 radical will come at 3 positions. At as we know, it's a 1, 3 biradical. So 1, 2, 3. Another biradical will come here. So this is the we have detected or identified this 1, 3 biradical. Look here also 1, 2, 3. So there are two sides. 1, 2, 3, 1, 2, 3 in these positions. 1, 3 biradical. 1, 3 biradicals. And what? Between two radical sides, what we have? We have one CH2. This is a CH2. See, one radical here, one here. We will have one CH2. This is the CH2. So definitely we have two hydrogens. One is here, another is here. Let's say it's HA, and let's say it's HB. Okay. So if HB migrates, now from here hydride shift will happen. Okay. If H migrates from here to here, then we will have a double bond around these positions. Now, 1, 2 hydride shift occurs. If 1, 2 hydride shift occurs, we will have two things. If this breaks here, then we will have this. If it breaks here, and this will is going to attach here, we will have these things. These things. That is, after photoirradiations of these compounds, we are going to get four products. This is number 1, that is minor, this is number 2, this is number 3, this is number 4. So how many keto product we can observe after this photoirradiation? The answer is 4. Among them, two 6 member and two 7 member. And both cases we have realized